Last episode, we counted and bucketed. Now we do arithmetic between columns and use it to catch a bill that doesn't add up. Two numbers, one story. Tenure alone says how long. Monthly charges alone says how much per month. Multiply them and you get the story they tell together. Roughly what this customer should have paid in total. That's an interaction feature. Now compare that expected total to the actual total charges in the data. Divide one by the other. If the bill is consistent, the ratio sits right around 1. That's a ratio feature, this relative to that. Why bother? Because a ratio far from 1 is a flare. Maybe a promo, maybe a mid-contract price bump, maybe a data glitch. The raw columns hide it. The ratio makes it jump out. Models love a feature that already points at the weird rows. And the same discipline as always. These are row-wise, expected total, and the ratio use only that customer's own tenure, charge, and total. No cross-row stats. So we build them after the split and apply the identical formula to test. Here's the whole thing in one file. We split, build the interaction and the ratio, and plot actual against expected. Load, drop the ID, coerce total charges to numeric. Split, train and test, stratified on churn, random state 42. Build expected total as tenure times monthly charges, the interaction, then charge consistency as the actual total over that expected total. Apply the exact same two lines to train and to test. No fitting, nothing shared, pure row math. On the training set, the median consistency lands right at 1, and actual versus expected line up almost perfectly. Correlation essentially 1. Ratios sharpen the numbers. Next we go the other way. Chop a smooth number like tenure into bins and learn the cut points on train. If this helped, like and subscribe for more.